Hi everyone, welcome back to the Data Couple. Today we are going to be solving all the SQL problems in Namaste SQL. I hope you guys have heard about this particular platform where you get to solve different kinds of interesting, intriguing, and real world relevant SQL problems. Now, I do not have a premium account yet, so I'll just go ahead and go to the coding problems and then I'll choose the free ones and then I will start working on the free problems. Let's see how much time it takes. So I think there are around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5, 6, 7. Okay, around 17 problems? No, 18 problems. 18 problems in free tier. So let's go ahead and start solving this. Okay, so Namaste Cart, an e-commerce company, has observed a notable surge in return orders recently. Okay, this aspect that a specific group of customers may be responsible for a significant portion of these returns. Yeah, okay. Returns is, I think, similar to the ones that we return in, Amazon or Flipkart or Myntra. Same thing they're talking about here. They suspect that a specific group of customers, let me just zoom in a little more. So, they suspect that a specific group of customers may be responsible for a significant portion of these returns. To address this issue, their initial goal is to identify customers who have returned more than 50% of their orders. This way, they can proactively reach out to these customers to gather feedback. Hmm. Okay. Write in SQL to find list of customers along with their return percent round to two decimal places. Display the output in ascending order of customer name. Okay. So customer name, order date, order ID, and sales. So I think they want to understand at customer level what is the return rate. And returns is order ID and return date. So we have customer name, right? And then we have date, we have order ID and sales, right? So this first table T1, let's say it's all about what's your order and it's not about your return order. Now, let's say the second table that we have, second table is all about returns and then we have order ID and return date. Now, any of the order ID which are represented in the second table, those are the order IDs which are returned, right? So we can say that we can probably create a joined table with the first and the second with the join key as order ID. Let's say we can call it as return order ID, right? So if it's return order ID, then if order ID 1 is bought and then again it is returned, so that means order ID 1 is counted within returns. And let's say order ID 2, it is bought but it's not returned. So there will be no match and this will be blank value basically or null value. Let's say order ID 3 is there, again order ID 3 is returned, and let's say all of these orders are bought by the same customer, date might be different, and so basically what will be my return rate then? So A's return rate would be 2 out of 3, so that's essentially 67%. So this is what this particular problem is looking for an output. So customer A's return rate is 67%. Some customer B's return rate can be 30%. Another customer C can be 0% or D can be 100%. Something like this. So this is essentially what this problem is wanting to understand from us. So let's go ahead and start to code this. All right. So we can remove this. So let's take a CT or we can say return count. Let's name it, right? Select we can take the left table as orders. Select O dot star, comma, let's say order ID, right? R dot order ID as, let's say, return order, right? And okay, this is the order ID. This is not a order and item ID. So I was just thinking maybe in one order, if there are multiple items and only one item is returned, then we would need to go even deeper. But right now it's only at order ID level, so we don't need to think about anything else. Right now, let's do from orders as O left join, because we want to keep all the order IDs which are ordered, and we want to keep the order IDs which are returned as well. Let's say that all the order IDs which are here might not be there in the second table, right? Because all the order IDs might not be returned. See, order ID 4, 5 is not appearing in this second table. So that's why we need to do a left join here. So left join with returns are on O dot order ID and R dot order ID. So this is our first table. Select O dot star. Then, so basically what will happen? So order ID 1 will have 1 as return ID, 2 will have 2, but then 4 will have null. So we'll have to essentially calculate this. So select customer name, right? And then we'll have to take a summation of the overall order IDs. Sum or count of order ID as orders, or we don't need orders, we just need the percentage, right? So expected output, I think that is what the output is. So let me just code it once and then we'll check. Then count of, so we will basically count this one. Case when order, return order is null. Then 1. End. So this is what the numerator is, and denominator would be count of, not case when, we'll just take count of distinct orders basically. Or if this is distinct only is what I'm thinking, this is there's no duplicates within the order ID, so we'll just take count of order ID. We can take a multiplication by 1.00. This will help you to rounding the numbers, decimal numbers to 2 decimal places. From, we will say return count. We can give an alias saying return rate group by customer name. Now, just to be on the safer side, what we can do, we can give a round function and give comma 2 as here, as return rate. So I think this looks fine with return count as select O dot star. We are selecting everything, R dot order ID as our order ID, left join returns are on order ID and R dot order ID. This is fine. Now there would be some order IDs within the first column, that count of order ID, everything. Okay, so till now this is clear. After that, what will happen? Let's say if I'm counting the order IDs from the first table, then there should be all the order IDs which are existing within the table. That means including return and only orders, everything. But the numerator will only check out case when return order is null. Then 1 is not null. Sorry, is not null. Then 1, otherwise end. So that will be your return rate, right? Okay, so let's check run code. Customer name and return rate. Not sure what the expected output is. Should we check? 75% Alexa and Ankit. Okay. Do we need something like that? This way they can proactively reach out to these customers to gather feedback. Oh, okay. They address the issue. Their initial goal is to identify customers who have returned more than 50%. Okay, got it. From return count is this. We have to select only the ones who have returned more than 50%. So first let me multiply it by 100 because they need the percentage it seems. And then I will have the, okay. So we can do one thing. We can keep the order ID here and immediately calculate these. Calculate this in the upper table itself. Let's do that. The return rate is calculated here already. Left join from this on this group by customer name. Fine. So this is the one query. You are joining on the same query. You are actually counting the calculations also in the same query. After that, what will we do? We will just select the customer name, return rate, and also customer name. Group by is fine. Group by is not needed. Group by is there already on top, where we would say where your return rate is greater than 50, and we will have order by ascending order of customer name. Customer name ASC. Okay, I don't think this is needed either. Got it. Yeah, this is fine. So we have customer name, we have round of the overall metric that we are supposed to create. We have left join, returns, O dot order ID, R dot order ID, and group by this. Select customer name, return rate from return count. Well, return rate is greater than 50, order by customer name ASC. Answer is correct. Okay, fine. Hopefully you understood. Let's move on to the next question. Product category. You are provided with a table named products containing information about various products, including their names, prices. Write a SQL query to count number of products in each category based on its price into 3 categories below. Okay. Display the output in descending order of number of products. Okay. Low price for product with a price less than 100. Medium is 100 and 500. Products with greater than 500. So product ID, product name, and price. The containing information about various products, including their names and prices, to count the number of products in each category based on its prices. Each category. Okay. Descending order of number of products. Okay. So basically we have to create a category first. Let's select a category and then we will calculate products within the category and then we will sort it by ascending order. So if I show it, so let's say so we have prod ID, then we have, let's say, price, and we have product name, right? Then we have to create a category in such a way that I would have to finally return within this category. There are, let's say, if it's low, mid, or high, based on that, how many products are there? 20, 50, or 70. If that is the case, we have to start with 70, 50, and 20. So that will be high, mid, and low. Okay, that's what it is. Let's just go ahead. Information about various products, including their names and prices. Write a SQL query to count number of products in each category based on its price into 3 categories below. Okay, sure. Select. We will have product ID for sure. We don't need it actually. We can just directly start with case when price is less than 100, then low price. When price is between 100 and 500, then medium price. When greater than 500, then high price. End as product category. If that is the case, then we will be count product ID. as count products from products group by this whole thing. Okay, and end as product category. So this much is needed, right? And then we'll have to order it by a descending order of number of products. Order by count products DESC. Let's run code and check. Low price is 9, 4, and 2. Is this what we need? Yes. We need to name it number of products. Okay. Number of products. Category, and I have written as product category. Let's evaluate. Answer is incorrect. Okay. Let's see. Low price. Okay. Let's run code and check. Count products in order clause. 942, right? Okay. Let's do. Yep. All right. Let's move on to the next question. We have done this. Let's go to library borrowing habits. All right. So imagine you are working for a library and you're tasked with generating a report on the borrowing habits of patrons. You have two tables in your database, books and borrowers. Write a SQL to display the name of each borrower along with a comma-separated list of the books they have borrowed in alphabetical order. Display the outputs in ascending order of borrower name. Okay, so there's books and borrowers. So book ID, book name, and genre. Borrower ID, borrower name, and book ID. Okay, so what I have to return is that book ID, book name, genre is there. We'll just have to return the borrower name and borrowed books. P and T. Okay, fine. And that has to be alphabetical. Okay, let's do that. So what will we do? We will first append the book names here, right? So we have the borrowers. We need the borrower table as the first table. And then we will just append the book names there because genre is something that we do not need, right? So select, okay, let's do borrower. Do I need name? Yes. Borrower name. Okay, let me just explain it to you first. So let's say if we have the borrower name ID and the book ID, right? So first what will we do? We will just take the book name side by side. Now this is the borrower name and this is the book name. Now at first only we'll have to do a join because and we cannot filter out because we need all the borrowers and we will probably need all the borrowers that had borrowed some book. So that's intuitive from the name itself. Probably each of the borrower will have a book in the books table. So let's say borrower name is A and ID is some 1, 2, 3. Book ID is let's say some 1, 2, 3, and book name would be A, comma B, comma C, or X, comma Y, comma Z. Something like this. So that's all we need. First, we need to map the book name here, and then we'll have to combine by comma separated cell creation. Let's do. So select borrower name, comma. We will have book name from borrower as B, join books as C on B dot book ID, C dot book ID. Right? Yes. So borrower name, book name is this. Is there any repeat of names? No. No? Okay. No worries. So select borrower name, book name, borrower as B, join books as C, this and this. Book name would be what? We will have a string ag. Right? So we will use string ag function where we will use book name, comma. We will probably just use a comma as a separator. As borrowed books. So string ag is a function which helps you combine all the different cells of a particular group into one cell. So let's say if this girl, Alice, has borrowed Pride and Prejudice and Great Gatsby. So rather than having two separate lines, we will push those into one line by using a comma in between and group by borrow name. Right? Let's run code and check. Borrower doesn't exist. Borrowers. String ag does not exist. Okay, let me just take it. Go to MS SQL. Okay, so we have Alice, Great Gatsby, and Pride and Prejudice, and all that. Okay, so this is not correctly ordered. Okay, so here we'll have to use one other syntax within group order by book name. So specifically for string ag functions, if within the string ag, okay, so we'll have to sort the borrowed books also within the string ag column. So what will we do? We will use another function here. So within group order by book name. So we are using within group order by this. This is the particular function that is used within MS SQL Server. See, Pride and Prejudice in the Great Gatsby is sorted in the particular order. So we'll have to use, since string ag is a separate grouping function, so their sorting methodology within the group function is a little different. You have to remember this particular syntax. So we will use within group and then similarly order by, right? Okay, so let's evaluate. Answer is correct. Let's move on to the next question. Okay, dynamic pricing. You are given a product table where a new row is inserted every time the price of a product is changed. Additionally, there is a transaction table containing details such as order date, product ID for each order. Write an SQL query to calculate the total sales value for each product, considering the cost of the product at the time of the order date. Display the output in ascending order of the product ID. Product ID and their total sales. Okay, fine. So here is the table. I think I understand this. So let me just explain it to you. Or first, let's go through the example here, then I'll explain. So product ID is 100. 100 product IDs ordered on for 5th January as well as 21st January. And see, product ID 100 has changed its price from 150 to 170 by 121. And this is where we were ordering the product ID 100 once again. So first time my price would be 150, second time it will be 170. So we'll have to compare that. Keep on comparing that. Okay. So how do we calculate that my product ID and their total sales based on the ever changing price of the same product? So let's just explain this concept. So let's say you have product ID. So let's say I have a product ID, and let's say I have an order date, and then there's the price change date as well. Change date as well. So I would have to take the most recent price change date. If order date is 1/1, then and price change date is 1/1, I'll take this one. But let's say if order date is 1/3 and the most recent price change date is 1/2, then I'll have to take this one. Product ID is 1/1/1, let's say. Now what we can do, let's say we can take the price of the product. That's what you need essentially. So first day it will be 150, second day it will be 170, maybe third day it will be 190 or something similar. So if this is 15 and again the price changed on 13, then this will be 190. So total product number 1 would be making a sale of this much. So 320 and then around 510. Okay, so that's what we want. But one thing, so if my order date and price change date, we are mapping both of these, it needs to be, so order date needs to be greater than equals to price change date, right? That makes sense. But if that is the case, just understand, let's 15 will be mapped to 13, 12, 11, all of this. We'll have to take the most, like the latest price change date for all the order dates and all the previous price change dates, like from the combination of all the order date and previous price change dates. We have to take the latest price change date. We have to use a combination of joins and ranking function in this particular case. So what will we do? Essentially, let's take a CT first. So we will create, let's say price change base as select. So first table is the main table here, product ID, price date. Sorry, second table is the main date here, order ID, order date and product ID. So you can take the product ID and then you can take the order date. So let's take, because order ID is not needed, I think. So select p dot product ID, comma, p dot order date, comma, this would be, okay, not P. Let's take this as O. This is O. And we will take P dot product ID and P dot price. Product ID is actually not needed. P dot price. Do we have all the products which are in orders in the products table? Yeah, nothing is mentioned, so we will consider that only is true. Let's say all the products in the order table is already existing in the products table, right? So P dot price, comma, P dot price change date, price date, right? From orders as O, join products P on A dot product ID equals to P dot product ID. Product price change as, let's write select. So what will I do? First I will take the order date, product ID, and also I'll take the price dates. Okay, I will take price date mapping here. So select O dot order date, comma, O dot product ID, and I need price date, P dot price date, comma, P dot price. Yes, so I can do it this way. So what I'm thinking is, if I just quickly explain. So first I will take the prod ID, then I will take the order date, and then we will take the price change date, right? So here what will happen, basically one extra column, let's say product ID is 111 and order date is 15. So order date greater than equals to price change date can be 15, can be mapped to 13, can be mapped to 11. So let's say 15 basically will be mapped to all the three dates, given that I am taking the condition as O date greater than equals to price change date in mapping or in joining. Now I can take these two columns and then take a ranking function and take the highest rank or the latest price change date basically to be ranked as 1, we can only take out that row. In this case, what will happen? Basically, one particular column will be repeated multiple times. So 1 is getting repeated 1, 1, 1, 1, 1, like that, depending on how many times price has changed. But another piece what I can do is I can create a separate, let's say, bridge table where I can create order date and then their latest price change date, kind of like that. But I think that might be a lot more difficult given that I'll have to take every order date into consideration, not only the ones that had some order dates, because essentially for larger tables, every date would be a order date, right? So, okay, that might become more difficult. Let's not go into that direction. What I will do essentially first, I will take the order date, map it with price change date, take the rank and take the highest rank based on the latest price change data. If it got confusing, let me just write the query to you, follow step by step. I hope this will make sense. Now price change p dot price date. Sorry, price date, right? That's it. From orders O left join products P on O dot order date being greater than equals to P dot price date, right? And based on that, your prices also will pop up. So basically for same order date, if order date is 121, for product ID 100, there can be two columns, 121 and if order date is 121, then my price date will be two columns, 11 and 121, right? So there can be m cross n columns basically. So let's just take this. After that, what will I do? I will actually create a rank function here only. Rank of over partition by order date, right? We have to take order date and order by price date, O of order date, order by P of price date, and yep, descending. Descending because I have to take the latest as, let's say, rank function or rank 1 or rank, maybe rank of price change. We can name it like that. So that's it. That's all we have to do. And then after that, only select what's the expected output. I need the product ID, product ID, comma, total sales. Now, total sales would be sum of price, P dot price, or just price as total sales from product price change where rank price change equals to 1, right? Because I need the latest one. And then we'll have to group by product ID and order by product ID. Ascending, right? So let's run code and check. Price date, duplicate column price date. P dot price date. Oh, sorry. Okay. 100 and 101. Total sales is 257013840. Okay, clearly this is not correct. Okay, let's see. What have we done? We have taken order date, product ID, price, and price date. Now rank over partition by O of order date, order by P of price date. Partition by order date. Yes. Price date. DESC. Yes. From orders O, left join products P. Okay. Select product ID. So take out only where rank is 1. Okay. That's something. Then take the product ID, the sum of price. We have quantity. No, we do not have a quantity. That means we'll just take a sum, right? So Okay, let me do one thing. Let me debug. If I just do a select star from product price change, let me take this out. What's the output? So we have 1511, 1511, price is 1000 for the same product. Oh, sorry. And O dot product ID equals to P dot product ID. Yes. Now this will make sense. Yep. Okay. Yep. Run code. Yep. Evaluation. Answer is correct. Fine. Okay. So basically, of course, your main join condition is both the product type needs to be same and then order date would be greater than equals to price date. We cannot skip one. Sorry for that. Let's go to the next one. Okay. We have to go back and then check. Okay. 4 are done. Let's move on to product reviews. Okay, suppose you are a data analyst working for a retail company. Your team is interested in analyzing customer feedback to identify trends and patterns in product reviews. Okay, your task is to write an SQL query to find all product reviews containing the word excellent or amazing in the review text. However, you want to exclude the reviews that contain the word not immediately before excellent or amazing. Please note that the words can be an upper or lower or combination of both. Your query should return the review ID, product ID, review text for each review meeting the criteria, display the output in ascending order of review ID. Okay, so let's explain this. So we have review ID, we have product ID, we have review text. Review ID, product ID, product is excellent. Quality is excellent. Product is not excellent. Okay, expected output. So we have to only pick out the reviews where there is excellent, amazing, excellent, excellent, etc. Okay. So what will we do here? Now this is a quite simple query. Let's try to do this. So if the product is in fact excellent, that means what are we doing? We are trying to understand if the particular query contains either excellent or amazing, but it should not contain the word not, right? Not an excellent product. No, we should not be keeping that. Wait. This is wrong, right? Not an excellent product. That is not a good review. That's a bad review. Your task is to write a SQL query to find all product reviews containing the word this. However, you want to exclude reviews that contain the word not immediately before excellent or amazing. Please note that the words can be in upper or lower case or combination of both. Okay, so I think this is kind of a brute force method, because if we just give, let's say it contains amazing and excellent but doesn't contain not, then this particular review also will be out, but we need to uh, bring this one in output. So we have to make sure that not excellent and not amazing is particularly not part of the queries or not part of the reviews. Okay, so select star basically from product reviews where review text like amazing, lower of review text. Can we use this? Because it can be lower or upper or camel case. There can be any cases. So that's why let's just convert the review text to lower and then compare it with amazing. Or lower review text like excellent. Sorry, excellent. But it doesn't contain not excellent. And lower review, not like, not amazing, or not excellent. So what have I done here? I have just put, let's say lower review text is like amazing or excellent, both will do. And at the same time, lower review text is not like not amazing and not excellent. Okay, let's try to run. Okay, let's run through it. So review text like amazing or review text like excellent. Yeah, that makes sense. Either excellent can be there or amazing can be there. If it's and, then basically excellent and amazing both needs to be there in the same sentence. Now that is not the case. So or makes sense. And the review text not like not amazing. So after amazing and excellent is picked out. Not an amazing, sorry, not excellent or not amazing should be out. Review text not like not amazing. Okay, let's try this. Let me, if I just take this one out. Oh, I think I got it. Hmm. Got it. I need to write and here because if it's not within not, we have to give the and condition. So review text not like not amazing. Not amazing is not there, and not excellent is also not there. So either of not amazing or not excellent is not there. That is not the case, right? So both of not amazing, not excellent needs to be there. So let's run code. Yeah, I think this, yeah, cool. Yeah, this is correct. Perfect. Okay, got it. So basically, the main thing is once you are doing something is contained within a particular sentence and we have two conditions, then we can use or. But whenever we are telling that something is not contained, then there are two or more conditions, then we will have to use and. This is not contained and this is also not contained and also this is not contained. We cannot use or there, right? Correct. Okay, let's move on to the next question. Loan repayment. Loans. Okay, let's look at the question first. You're working for a large financial institution that provides various types of loan to customers. Your task is to analyze loan repayment data to assess credit risk and improve risk management strategies. Okay. Write a SQL to create two flags for each loans as per below rule. Display loan ID, loan amount, due date, and two flags. Okay. Loan ID, loan amount, due date, and the two flags. Okay. Fully paid flag. One, if loan was fully repaid irrespective of the payment date, else it should. On time flag. One is if the loan was fully repaid on or before the due date, else zero. Wait. Fully paid flag. One, if the loan was fully repaid irrespective of the payment date, else it is zero. And on time is if the loan was fully repaid on or before the due date. Got it. So loans is loan ID, customer ID, loan amount, and due date. And payments is amount paid, loan ID, payment date, payment ID. Okay. I think I fairly got the idea. Let me explain. There is loan ID in both the columns. That means I need to map or join using loan ID. Customer ID is not needed. We just need to create loan ID, loan amount, due date. That's it, right? Loan ID, loan amount. Customer ID is not needed. We need to make sure that payment date, amount paid is this much. Amount paid and loan amount should be same. Loan ID should be same. That's the joining condition. And also my payment date is less than equals to due date. We have the due date. And then we have the loan amount, right? Customer ID is not needed here. Then we will check if my current payment date is less than equals to due date, and if loan amount is less, paid amount is less than loan amount. If that is the case, then it's 0. So 2 flags, right? So fully paid and I think fully paid before due. So basically this is the left table. So this will be the left table and these flags will come from uh, the right table. Now here in this particular case, the right table is not at loan ID level. This one is at loan ID level. First we need to make the right table come into loan ID level and then we need to create the flags. So let's go step by step. First we will bring the right table into loan ID level. Then we will match based on the condition. Fully join will be based on loan ID equals to loan ID. Then your latest payment date is no, it doesn't contain any date condition, and your paid amount is greater than or equals to loan amount. If equals to, then 1, else 0. A fully paid would be based on loan ID, due date and payment date, as well as the loan amount and payment amount. So those are the two joining conditions that will be there. Let's go ahead and we'll create that. So first, I'll have to create a CT. So with, let's say, loan temp as select, we would get loans. So L dot loan ID, L dot loan amount, loan ID, loan amount and due date, L dot due date, from loans, right? And we'll have to join loans on left join L. Okay, wait. First, we'll make the payments table. Payments as or payments temp. First, bring it onto loan ID level because payments table, if you see, is not at loan ID level. Loan ID is repeating. So let's have that. So select p dot loan ID, comma, maximum of payment date, because that's the last date, as pay date, comma, amount paid would be sum of at loan ID level, right? Anything that has been paid back as paid amount from payments grouped by loan ID, right? So this is at loan ID level now let's check, comma, loan temp as select loan ID, loan amount from loans L, left join, this is the table, payments temp P on L dot loan ID, P dot loan ID, right? And then we will have due date and then we'll have to create the flags as well. So case when loan ID, L dot loan ID equals to or equals to L P dot loan ID and P dot loan ID and due date payment date is less than payment date is less than equals to due date. Yes. And Fully paid flag. Sorry, loan amount and amounts paid. Paid amount equals to loan amount. Loan amount. Then 1 else 0 end as on time flag. Same thing, only the case when L loan ID equals to P loan ID and payment date is not needed. Paid amount equals to loan amount. Then 1 else 0 as fully paid flag. Paid flag. From loans L left join payments stamp P on N loan ID, P loan ID. Okay, that's it. We do not need another CTE here. Let's run. Check the manual left join on loans L. Sorry. P dot loan ID, unknown column P dot loan ID in the field list. P. Payment date in the field list. Payment date, right? Yeah. Group by loan ID. What? Payment date. Pay date. Okay. Loan ID, loan amount, due date, on time flag, and okay, this needs to change. Zero one zero one one 01010. Yeah. Okay. So that's what it was. We had to create one particular CTE and then create the conditions and create the flags based on the condition, and that's it. Should be correct. Yeah. Cool. So let's move on to the next question. Not this. Let's go back. Okay. So let's move on to the next one. Lowest price. You own a small online store and want to analyze the customer ratings for the products that you are selling. Okay. After doing a data pull, you have a list of products and a log of purchases. Okay. Within the purchase log, each record includes the number of stars as a customer rating for the product. Okay. For each category, find the lowest price among all products. For each category, find the lowest price among all products that received at least one 4-star or above rating for the customer. Okay, so basically the least price products which are receiving higher like positive reviews from customers. So we can promote those, right? More. So see, Indian customers are always looking for cheaper products which are more usable, and it's cheap but somewhat like it works fine. So I think we are looking for those kind of products to pull for each category. If a product category did not have any products that received at least one 4-star, the lowest price is considered to be 0. Okay, got it. So if a product category did not receive any 4-star, then it's considered to be 0. The final output should be sorted by product category in alphabetical order. Okay, this products table and then this purchases table. So in products we have category, ID, name and price. And in purchases we have ID, product ID and stars. Okay, so I think we have the ID, name, category and price in the products table already. And if we just map out the stars or reviews with this particular table, I think we have pretty much everything. I think ID does not matter. We don't need it. Product ID is the same as ID. So essentially, there's just one more column that we need to map with the products table. That's stars. We can do that. And I think product ID is repeating. Yes, product ID is repeating indeed. So we will just take a yeah, so anyway, after mapping, we'll have multiple rows for the same product. And I think we'll be doing a left join here just to make sure, we are capturing all the categories. Also, what I think would be better and easy solution would be to create a separate temporary table having all the distinct categories, which will help us to map the final table at the end. Let me explain you what I am talking about. Okay, so let's say we have category and then we have product ID and then we have product name. Okay, we have the price and we will map out the stars as well here. Now, each category level and product ID level, there will be multiple rows based on how many stars the customers have provided. Right now, let's do one thing. We will only pick out the records which are having greater than equals to 4 star, right? So we will only filter out those categories, so that way we only have the records which has some products at least which has at least 1 4 star, right? And then finally we will, by category, we will group it by the records, we will group it by category to understand what's the least price that we have available, where all our reviews, we have at least one reviews which is greater than equals to 4, right? So that's one that we will get. And these categories, mind you, might not contain all the categories that we have in the overall list. So that's why it's better to maybe create a table A where we have just the categories available separately. So we have categories, and then table B will contain only the categories and their least price. At the end, what we will do, we will map out these two tables, and then by category, of course, and any category which is not appearing here, we will just have the value to be 0, and then rest can have 30, 40, whatever is the least price which is getting the highest review. So this in this problem, what are we trying to find out? We are particularly trying to find out any cheap product which is long lasting, whose reviews are really good, so that we can bring those products out, particularly for a better ranking algorithm or for better user journey, especially for Indian customers, because we are always looking for cheaper products which are long lasting. Okay, so let's start. So I will create a table. Let's say product purchase as, so select p dot star comma pu dot stars from products as p left join. Actually, we do not need left join. We'll just need, yeah, just join is fine. Join purchases as pu on p dot product or p dot id equals to pu dot product id, right? Where stars greater than equals to 4. So we have the basic table ready, and then we will create the temporary table where we have just the distinct categories. Or we can just join it directly actually. Okay, let's do that. Let's take category, comma, Qualys minimum price, right? Comma 0 as price from product purchase. No, actually, let's do a left join. We'll create a temp table here only. We are not creating another CT. Distinct category as category from products. Okay. So this is table A. Join, left join actually. Product purchase PU on A dot category equals to PU dot category group by A dot category. Right? With product purchase as select P star, PU dot star. So basically this table is clear, right? We are joining based on product ID and we are filtering only the columns where it's greater than or equals to 4. So we have P dot star and PU dot star, basically 5 columns total. Then finally we are taking category and minimum price 0 as category from, oh, here we'll have to make A dot category, right? Because category column is present in product purchase as well. We do not need that. A dot category as category qualis minimum price comma 0. Anywhere there's minimum price not available, we will just keep it to 0. And this is also, oh, I'm really sorry. We'll have to pick out the least price. No? So select category comma minimum price. Or actually, we can even put this table into instead of this one. Select category, comma, minimum price from product purchase group by category PU. Okay. So this way we'll have category in this table, category in this table as well. And then we're just matching. Right? Okay, let's run code. Unknown column price in the field list. Price. Price. Okay. Apple, orange, cherry. Okay, I have to group it by. Order by category. A dot category, let's say. Cool. Yeah, so this makes sense. Now let's think about how can we further optimize this problem. So let's say when we are actually joining, we are filtering based on stars greater than or equals to 4. We can actually take out the category and minimum price in this particular section itself. We don't have to create a separate section. Let's do that. Minimum price is price where stars are greater than or equals to 4. Let's group it by category. Okay. And then we do not need this. We can just do select distinct category is fine. We'll just do product purchase. Let's run code. Syntax. Sorry. Yep. So I think this is a more optimized version. You're not having to call separate subqueries within the joining segment. So you're just creating the base table here itself, and then you're simply matching with the temporary table that you have created. That's it. Let's evaluate. Yep. Answer is correct. Okay. Okay, so that was all for today. We solved about, I think, 1, 2, 3, 4, 5, 6, 7 problems, and all the rest of the problems we will solve in the second part. So stay tuned and let us know if you would like us to go and solve any other kinds of problems as well. That will really help us a lot. All right, so take care and happy practicing.